right, on to number 7. Take a moment and read it. Let's go through it. All right, it asks for the pendulum period. So right away, my recommendation would be to jot down the equation. So the period of a pendulum T is 2 pi times the square root of the length of the pendulum divided by the strength of gravity on whatever planet you're on. Now, notice, importantly, mass shows up nowhere in this equation. So mass doesn't matter. Now, I know that seems kind of counterintuitive, but that is the actual fact, and we'll show you that here in just a moment. So we actually don't even care about any of the answers here. It's saying we're going to change things. So here we would have half the mass. Here we'd have the same mass, but a fourth of the string length, and so on. It turns out the only thing that affects the period is the length of the string. So this one's kind of straightforward. This should be a gimme, though I think it's tempting to want to go for one of these where maybe you increase the mass and lower the length of the string or something like that. But we don't need to do that at all. It's just the one where the string length stays the same. So our answer is A. In other words, L is the only factor here. What I mean by that is that we're not changing planets. Pi is a constant and 2 is just a number. If you'd like to be more convinced that this is actually the case, what you can do is look at the pendulum. You might remember that I mentioned several different times that we need to keep our swings small for this to undergo simple harmonic motion. So I'm actually going to reset this here. And what we're going to do is, I've got my stopwatch. That's going to be really helpful here. I've got it set to the maximum amount of, the maximum mass and the maximum length. So it's going to be easiest with the maximum length to do this. I'm going to pull this over to, remember we don't want to go more than 10 degrees. I'll set it to 10 degrees. And we'll let it swing. It's going to swing back and forth. And what I'm going to do in a moment is I'm going to start it in time 5 periods, and then we'll compare that to a smaller mass. See if we're right. So let me do that. Start. 1, 2, 3, 4, 5. Okay. I got almost exactly 10 seconds, so I'll jot that down on my paper. You can see I wrote the time for 5 periods is 10.01 seconds. Now keep in mind, we're probably going to have a little bit of uncertainty in when we've clicked, but I'm going to keep the length the same, as we said. That's the answer that we chose. Keep the length the same. And I'm going to reduce the mass to its minimum possible amount in this system here. So it visually looks like nothing changed, right? It looks like it's just carrying on, but let's actually get some data here. We're going to time 5 swings one more time. Start. 1, 2, 3, 4, 5. All right, 9.91. I'm pretty convinced there. That was 9.91 at a mass of 0.1 kilograms. Now, you could do this a bunch of times, and within uncertainty, you'd get that the times are exactly the same. Now, watch what happens when I change the length. What we're saying is that length is the only thing that really matters. So let me crank this back up to our original amount. This was the one we got around 10 with. Remember, it should be 10 no matter the mass. Let me change the length of the string. Watch what happens. Let's record 5 here just for the heck of it. 1, 2, 3, 4, 5. Okay, look, it reduced by just about half. Okay, and so that's the basic premise here. The only thing that matters when it comes to pendulums is the length. It actually matters that the mass does not matter. Now this is kind of cool. We can transport this to other planets. So instead of Earth, we could go to the moon. Now the moon has much less gravity. Look at this. The period now. I'll start it out here. 1. That was 1. 2 swings. Take a look at that. 2 swings on the moon, and I'm already around 10 seconds. That's 3. Okay. So I can change the planet that I'm on. On the moon, there's less gravity, so the period goes way up through the roof. So anyway, not too bad on that one. I encourage you, if you haven't yet, to do play around with this simulation. It's a lot of fun. Thanks, folks.